Hello everyone, I'm Martinus Bagus Wijaksono and today I would like to present system identification for second order and third order. System identification uses mathematical models to explain and regulate dynamic systems. So let's say we have an example like this is like a mechanical system here, and then from here we can simplify the system to be like this. There is force here and then another force in the opposite side. And from the simplification, we can write the equation here. And then based on this equation, we can get the transfer function of our mechanical model. In the world of control system, it's a fundamental tool for enhancing the performance of various systems, from manufacturing processes to robotic. Whether working in engineering, manufacturing, or any field involving complex systems, understanding system identification can lead to more efficient processes and better control strategies. Here there are some components and some components of system identification. First is the data collection. In here, we can gather input and output data from the system. And then model building. Here, we can create a mathematical model represent of the system. And then the last is the model validation. Testing the model's accuracy with the new data. So, system identification is a crucial tool for understanding and optimizing control systems. Next, we can try the system identification using MATLAB software. First, we can input the data. This is the data of amplitude. And then next is the data of the phase. And the last is the frequency. After that, we can check the system identification by typing ident here. So after we have the system identification window, then we can choose the frequency domain data here, and then for the data format for signals, then we can choose the frequency function by amplitude and phase here. And then for the amplitude, we can use the M data. For the phase, we can use the P data. And then for frequency, F data. For the data name, I will use 40 bars. And then for the frequency unit, just leave it as it is. And then for the sample time, we can type 0.005 and then click import. So right now we have the data already added into system identification. Next, we can choose the transfer function model in the estimate here. And then since we want to try the second order and third order, we can put the number of poles here is 2, and then number of zeros is 1 for second order. And then we can estimate. And After that, we have this result of our estimation progress. Next, we can check the model output here, and we will have the best fit value of our first transfer function here. And then we can try to the third order. For the third order here, we can type number of poles as 3, and then number of zeros is 2. Again, click estimate to get the estimation progress. After that, you will see here that our best fit value is increased. This is better compared to the previous one. We can check for the fourth order, put the number of pole 4, and the number of zeros 3. Again, estimate. Then we will have the value here. Okay, we will check from the second order. So we can drag and drop the best fit of our transfer function to the workspace here. Just click the first transfer function and then put it to the workspace here. So we will have our first transfer function into the workspace. You can type TF1 here, and then this is our transfer function, and we can put the Laplace transformation here by typing S equal to TFS. And then we can type our transfer function here into a P variable. Next, we can print our transfer function by typing the step P. So this is the step response of our transfer function. And we can put into a PID. So here we will put the KP, proportional coefficient. The value here is about 300, and then we can put the KP into PID. And then the last, we can check it into PID tuner. This is our PID tuner interface here. So from here we can determine the type. We can use P, D, P, I, or PID here. So based on the graph, we can tune so that we have the best fit parameter here. You can increase the value until you have best fit parameters. So after we satisfy with this condition of our system, then we can check here, show parameter here, click here, and then we will have the controller parameter of KP, KI, and KD here. Then we can put it into our system so that we will have this kind of response in our system. And then for the third order, fourth order, and so on, we can use the same way to make the PID tuner of our system. Okay, this is the end of my explanation about system identification of second order and third order. Thank you for your kind attention.